Okay, guys, this is intermolecular forces and intramolecular forces. I will try to get you another copy of this graphic organizer that's prettier and nicer and kind of looks like this, but in case I don't, make sure you have a copy of this in your journal. It's kind of a intro to bonding, kind of, well, not intro to bonding, but how do I determine if I have intermolecular forces or intramolecular forces? Okay, and then what types of bonding do I have? What kind of forces do I have? Excuse me. All right. So first thing I want to talk about, we have bonding. We have three types of bonding. We have ionic, covalent, and metallic. Ionic bonds is a transfer of electrons. It's between a cation and an anion. The electrons are transferred over to another atom or a group of atoms. Then you have metallic, which is a sea of electrons flowing through, and this is what gives it malleability, ductility, conductivity. The electrons kind of slide over each other, and it's between a metal and another metal, and that's basically all you need to know about metallic. Then you get into covalent bonding, and when you get to covalent bonding, you have a little bit more work to do. Covalent bonds are between a non-metal and a non-metal, and they can either be polar, non-polar, or they could be a network solid, which we'll talk about later. But if you have a polar bond, that means that you have what we call it's almost like a magnet. Part of the atom is partially negative, and the other part of the atom the molecule is partially negative, and the other side is partially positive. So it kind of looks like this. So like we're gonna take a water molecule. Okay. Excuse me. The hydrogens and the oxygen, looks like a little Mickey Mouse, right? Hydrogens have a slightly positive side to them, and this has a slightly negative side to them, the oxygen. Because most of the time when you're sharing electrons, most of the electrons are going to go to your oxygen side. So you could think of it like a magnet where you have a positive side and a negative side. And that's a polar molecule, or a polar molecule. So what happens is polar molecules will have a force that's holding them together, where the positive side is attracted to the negative side. Okay? So opposites attract. So in polar molecules, excuse me, you'll have a certain type of interaction, and that's where the little interaction, take it back. That's where the force is. So I'm going to go ahead and get rid of this because in actuality this is a polar molecule, but there's something else I'm going to put there instead. Okay, so then you have hydrogen bonds. Hydrogen bonds, we'll talk about some more too, and then where the polar molecules can make hydrogen bonds or dipole forces. Then you have nonpolar. That's where the electrons are shared equally. This is when electrons are being shared unequally. So let's just put that here, unequally, and this one is equally shared. Okay, and if they're equally shared, you have London Dispersion Forces, or LDFs. Okay, and then network solids. That's something totally different. I may or may not touch on that, but just have them there in case we do it in class. So what is the difference between an intermolecular and an intramolecular force? Well, intermolecular is is attractions between molecules. So that is these right here. These are the intermolecular, right here. Those are intermolecular forces. Intramolecular is within the molecule. So right here, where there's a bond holding this atom to this atom, so kind of like this, we have a bond. So this is the intramolecular. That's within. These are very strong bonds. These are forces, and they're weak. Okay, so these are weak. These are strong. Okay, all right. So intermolecular forces are forces between the molecules but they're much weaker than a bond because they are between molecules, not between atoms. Okay? So we have three kinds of intermolecular forces. They are the dipole forces, they are the hydrogen bonds, and they are the London dispersion forces. So those are our three types of intermolecular forces. So if you'll write those down, they are your dipole forces, your hydrogen bonds, and your London. These are London dispersion forces, or LDFs as we call them. Okay. All right. Dipole forces exist between a positive and negative end of a polar molecule. So this is what I was talking about here, positive and negative. Those are the dipoles. This would be a dipole. And a dipole basically means we got two poles and we're attracting to each other. A pole means, we have positive and negative end. Hydrogen bonds form a dipole attraction between hydrogen and another strongly electronegative atom. So here's our hydrogen. I'm going to put this back up here. Here's my oxygen. Here's hydrogen. Okay, here's my oxygen. Hydrogen is bonding to oxygen. Now, with hydrogen bonds, you have HFON. H will bond with fluorine, oxygen, or nitrogen. Kind of like phone home from ET. H phone. Okay, phone home. Then we have London dispersion forces. This is the last one. These are between atoms and molecules caused by instantaneous. So these are instantaneous dipoles. That means that what happens is sometimes, so like we have a hydrogen with another hydrogen, sometimes these electrons spend more time over here and cause this to have a slightly positive and this to have a slightly negative for an instant. And these are London dispersion forces, and they're kind of that idea there. Between atoms and molecules, okay? So dipole is between two molecules of opposite, positive plus negative. And you have the hydrogen bonds, which have the H phone. So we're looking here for electronegativity. So hydrogen bonds. You have hydrogen plus fluorine, oxygen, or nitrogen. And this has a 4.0 electronegativity, 3.5, and a 3.0. These are the only ones that make hydrogen bonds. And it has to be between a hydrogen of one molecule and an oxygen of another one. So these are dipoles, but this is also a hydrogen bond here, if you make this water. All right. The hydrogen bonds are 5 times stronger than a regular dipole. Okay, so that's kind of how you know the difference. These are a little bit stronger than a regular dipole. And the weakest ones we have are London dispersion forces. Now, why do we have these? Well, this helps with when we have different types of bonding intermolecular forces. It helps us to determine if it's going to have a high high melting point, boiling point. So it gives us some of our properties of our molecules. So the larger the nonpolar molecules, the higher the boiling point. So if we have nonpolar, if you have a higher nonpolar molecule, the higher the boiling point. So kind of keep those things in mind too. But this one is momentarily creates a dipole. That's the idea behind these. So we will talk a little bit more about these in class, but that's just a general idea. I will try to get you a copy of this. If not, it will look like this graphic organizer to help you. The other thing that with bonds that we need to talk about as far as whether they're dipoles or London dispersion has to do with symmetry. And we'll talk more about that when we do VESPR. Okay? So write all this down. I know it's a little confusing somewhat, but I will get you some information in class especially this one here. So, oh no, I know what I was going to say. Okay. So, when you're looking at this, these are the highest bonds that we have, ionic and then covalent metallic. When you go to covalent, these have a higher force, the hydrogen bonds, than the dipoles. They have a higher force than nonpolar London dispersion. So if you have a polar molecule, determine if it has a hydrogen bond. If it doesn't have a hydrogen bond, then it is dipole. If it has nonpolar, then it is London dispersion forces. That's kind of how this works. All right. Y'all have a wonderful evening.